Section B, Modules. Module 1, Matrices. Question 1. The car park at a theme park has 3 areas, A, B, and C. The number of empty and full parking spaces in each of the 3 areas at 1 p.m. on Friday are shown in matrix Q below. Part A. What is the order of matrix Q? We know that the order of a matrix is the number of rows by the number of columns. Matrix Q has 3 rows and 2 columns, therefore it is of order 3 by 2. Part B. Write down a calculation to show that 110 parking spaces are full at 1 p.m. The number of full parking spaces are shown by column 2, that is 50 plus 20 plus 40 equals 110. Drivers must pay a parking fee for each hour of parking. Matrix B below shows the hourly fee in dollars for a car parked in each of the 3 areas. Part C. The total parking fee in dollars collected from these 110 parked cars if they were parked for 1 hour is calculated as follows. P times L equals 207, where matrix L is a 3 by 1 matrix. Write down matrix L. Matrix L is going to be a column matrix with the full parking spaces, 50, 20, and 40. The number of whole hours that each of the 110 cars had been parked was recorded at 1 p.m. Matrix R below shows the number of cars parked for 1, 2, 3, or 4 hours in each of the areas A, B, and C. Part D. Matrix RT is the transpose of matrix R. Complete the matrix RT below. We know that the transpose matrix is obtained by swapping the rows and the columns of the original matrix. So column 1 in matrix R becomes row 1 in matrix RT, that is 3, 6, 22, 19. Column 2 in matrix R becomes row 2 in matrix RT, that is 1, 10, 7, and 2. And column 3 in matrix R becomes row 3 in matrix RT, 1, 3, 10, and 26. Part E. Explain what the element in row 3, column 2 of matrix RT represents. First of all, the columns in RT represent hours, 1, 2, 3, 4, and the rows represent areas, A, B, and C. The element in row 3, column 2 of matrix RT represents the number of cars parked for 2 hours in area C. Question 2. The theme park has 4 locations, Air World, Food World, Ground World, and Water World. The number of visitors at each of the 4 locations is counted every hour. By 10 a.m. on Saturday, the park had reached its capacity of 2,000 visitors and could take no more visitors. The park stayed at capacity until the end of the day. The state matrix S0 below shows the number of visitors at each location at 10 a.m. on Saturday. Part A. What percentage of the park's visitors were at Waterworld at 10 a.m. on Saturday? From the matrix, we can see that there are 400 visitors at Waterworld. Because we need to calculate the percentage, we divide this by 2,000 and multiply by 100, and that gives us 20%. Let Sn be the state matrix that shows the number of visitors expected at each location and hours after 10 a.m. on Saturday. The number of visitors expected at each location and hours after 10 a.m. on Saturday can be determined by the matrix recurrence relation below. Part B. Complete the state matrix S1 below to show the number of visitors expected at each location at 11 a.m. on Saturday. For this, we need to calculate S1, which is T times S0. So the number of visitors at Air World is 300, at Food World is 780, and at Water World is 620. Part C. Of the 300 visitors expected at Ground World at 11 a.m., what percentage was at either Air World or Food World at 10 a.m.? For this, we need the proportions from matrix T, that is 0.1 and 0.2 for the two worlds, air and food. There are 600 visitors at Air World and 600 at Food World. Therefore, to calculate the percentage, we need to multiply 600 by 0.1 plus 600 times 0.2, divide by 300 times 100, and that gives us 60%. Part D. The proportion of visitors moving from one location to another each hour on Sunday is different from Saturday. Matrix V below shows the proportion of visitors moving from one location to another at each hour after 10 a.m. on Sunday. Matrix V is similar to matrix T, but has the first two rows of matrix T interchanged. The matrix product that will generate matrix V from matrix T is V equals M times T, where matrix M is a binary matrix. Write down matrix M. First of all, a binary matrix is a matrix in which all the elements are zeros and ones only. We are going to start with the 4x4 identity matrix. And now we interchange the first two rows. And this is matrix M. Question 3. On Sunday, matrix V is used when calculating the expected number of visitors at each location every hour after 10 a.m. It is assumed that the park will be at its capacity of 2,000 visitors for all of Sunday. Let L0 be the state matrix that shows the number of visitors at each location at 10 a.m. on Sunday. The number of visitors expected at each location at 11 a.m. on Sunday can be determined by the matrix product V times L0. Part A. Safety restrictions require that all 4 locations have a maximum of 600 visitors. Which location is expected to have more than 600 visitors at 11 a.m. on Sunday? For this, we need to calculate V times L0. Notice from this calculation that at Air World there are 810 visitors. So this is the location that has more than 600 visitors. Part B. Whenever more than 600 visitors are expected to be at a location on Sunday, the first 600 visitors can stay at that location and all others will be moved directly to Ground World. State matrix Rn contains the number of visitors at each location and hours after 10 a.m. on Sunday, after the safety restrictions have been enforced. Matrix R1 can be determined from the matrix recurrence relation below, where matrix B1 shows the required movement of visitors at 11 a.m. Part I. Determine the matrix B1. For this, we need to calculate V times R0, which is the same as V times L0. Notice that we need to take 210 visitors from Air World and move them to Ground World. For this reason, the column matrix B1 is negative 210, 0, 210, and 0. Part 2I. State matrix R2 can be determined from the new matrix rule below, where matrix B2 shows the required movement of visitors at 12 noon. Determine the state matrix R2. First of all, we need to calculate R1, which is V times R0, we have already calculated that one, plus matrix B1. So R1 equals 600, 300, 520, and 580. We can now calculate V times R1. And let's have a look at matrix B. First of all, at air world, we need to take away 186 visitors and move them to ground world. And at water world, there are 644 visitors, so we need to move 44 visitors to ground world. For this reason, at ground world, we need to add 230 visitors. So matrix R2 is equal to 600, 288, 512, and 600. And this is the end of the solutions for Module 1 matrices.